Morning, folks. We have a couple of announcements. Let me remind you that in the Piazza Post which is now pinned to the top of the list by popular demand, there will be there's a notification, and I'll remind you of this now, that Tuesday Lab next week, of course, doesn't meet because it is on fall break. So the Tuesday Lab can demo their project anytime until the end of lab Wednesday night, which would be at 7:30. There is also a Piazza poll going on right now that the TAs are running to find out what days over break they should open up. Right now, the leading day is Tuesday. Yes?
When we demo on Wednesday, do both partners have to be present at the demo?
Do both partners have to be present at the demo? There is no particular policy about people being present at demos, and we would prefer everybody to be there, but if there's a conflict, no. Because obviously this is a rescheduling. Any comment about that? This was announced a long time ago and there was no comment at all on it. It's in the Piazza Post, which says modified due dates for all assignments. So it's been up for weeks now. I'm going to have the lab open all day tomorrow. Tuesday morning, can't be open Tuesday afternoon because of 2300. All day Wednesday, all day Thursday, and TAs will open up about 11 o'clock on Friday and be open up the rest of the afternoon. And then over the weekend, there's a Piazza poll which you should fill out if you are here and want to come to lab. Any questions about that? Do you feel that that is a fair amount of time demoing by Wednesday night? No comment. This is a tacit yes, folks. Okay. Tuesday, Piazza poll, dynamics. Oh, yeah. So I was messing around with the RAND function, and it turns out the documentation in the compiler says that this returns a number between plus and minus 2 to the 15th. What a surprise, documentation is wrong. This actually produces a unsigned int. So to make it into, let's say we wanted, for unknown reasons, we wanted a random number in the region of plus minus 1.5. One way to do that then would be to take the output of RAND, which is presumably uncorrelated bits, and it with 0, x, 1, check 2, f, 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 f. This construction makes a bit pattern which is equivalent to a fixed 16, between 0 and 3 uniformly distributed. And then we subtract off float to fix 1.5. And that makes a fixed point number between plus and minus 1.5 uniformly distributed. Whether, yeah.
Is the RAND and OX2FF, is that a fixed number?
This returns an unsigned int.
Yes.
By truncating it to, if I truncated it to FFFF, I'd have a number between 0 and 1 fixed point, because it's the low 16 bits of a 32-bit number. By putting the 2 here, I make this maximum be 2FFF, which is just 1 bit below 3. Does that make sense? So what we're doing is we are noting that the bit pattern for 3 in fix 16 is 0x030000, and just matching the bit patterns without going through the formalism of doing fix to int or int to fix. So this is a fast way of generating a number, a fixed point number between plus and minus 1.5. Any questions on that? Any questions on the dynamics I talked about last Friday and the approximations of what to do when you have a direct hit between two balls? The idea that if you have two balls whose Rij and Vij are parallel, that all you have to do to conserve momentum is to, on the outgoing ball, make, if this is the ith ball after the collision, its velocity will be Vj, and after the collision, the jth ball's velocity will be Vi. If the two vectors are collinear, or approximately collinear, then the condition to conserve momentum is they just swap velocities. You don't calculate delta V, you don't do any of the delta calculations, you just swap the velocities. And the question then is, how close to being collinear does it have to be before you'll notice a difference? And I claim that if Rij is less than 2, you surely will not notice a difference. Ij squared. Remember, this goes from 0 to 16 for a valid collision. One of the students said, should use 4, which is 1 radius, which I kind of like. 1 collision radius. So, and in any case, for a small impact parameter, for a small Rj, just swap the velocities. If the number is bigger than 2 or 4 as you choose and less than 16, then you should do the divide. You should do the fixed point divide by Rij magnitude squared rather than just divide by 16. If you just divide by 16, you will systematically underestimate the energy, underestimate the momentum, which will produce a fake drag. In other words, the balls will slow down too much. It's not the end of the world. It'll still work. It's been working for years, but it's slightly more accurate if you actually do the divide. Yes?
How are you going to check quickly that it's collinear? Because the only way that I can think of is to like take the vector and then divide it by the magnitude and check if they're the same vector for like Rij and Vij, but that seems slow.
It is slow, and what I'm claiming is that the only way that this can be very small is if they are
So
almost,
quick that
if
it
they're
will-
almost coming into each other. If they're going like this, Rij is not going to become small. So this is the test. So and doing this is good. Having a lower Rij cutoff is a good thing because whenever you do a divide by a short vector, short vectors have a large relative noise in their direction because of quantization error. And so whenever you do a divide by a short vector, you're asking for large quantization errors in the calculation. And by just simply swapping the velocities, you avoid that. Once the vector is fairly long, greater than 2 or 4 as you choose, then doing the divide by Rij magnitude squared is numerically stable. You're not going to generate some gigantic number because you divided by almost 0. Any questions on that? A couple of people asked me again about overclocking. Yes?
I'm a little confused about the parameter Rij squared is less than 2. So is that saying that they're collinear?
Louder?
Are you saying that parameter that equation gives whether or not it's collinear velocity?
I'm saying that the only way that the centers can get close together is if they're headed towards each other. If they're headed past each other, Rij quantity squared is never going to get small.
But what about their colliding this way? Like not like towards each other?
You're saying, what if they come in like this? So the relative velocity looks like that, or something.
Well, the relative
No, I'm sorry, no, the relative velocity is like that, right? It's almost 0, in fact. And Rij looks like this, that's collinear, and you just exchange the velocities. And how could you tell that they weren't? You look unconvinced.
No, I am this.
You're processing. Yeah, okay, I know. But there was that little edge of, I call BS there too. What was that?
Someone asked this yesterday, but do you actually have to bother switching the velocities? Because if they're that close, could you ever actually tell? Balls are the same color and everything.
Okay, so in this case, no, you don't have to switch velocities, but in this case, you do. Therefore, always switch velocities.
Why though?
You have a ball coming in fast. It hits a ball that's still. What happens?
If you don't switch velocities, then the one that still will stay in the same place.
And the other one will slide through it.
Right, and that's not what
It
happens.
will look the same.
Yeah,
as if
But you won't know.
But the thing is that they're overlapping. It's because they're overlapping and they're almost touching. It'll be exaggerated of a jump.
You could get a numerical instability, and it could actually add energy. But if you exchange velocities, then the physically correct thing happens. This one whizzes off, and this one stops.
you see the same thing.
It's like what's it called, Newton's cradle?
Yeah, but you see the same thing. Yeah.
You see the same thing, except unless you get unlucky and the numerical stability is such that you actually try and do the divide by 0.
No, but you won't be doing any divide. Instead of swapping velocities,
You just ignore the collision.
it just glides through.
Yeah.
You don't know what you want.
If they're all the same color,
Yeah.
okay, just do nothing. Yes, you're right. You're right.
If they're all the same color, like we wouldn't be able to tell.
Yeah, but Rij, it is a possibility that Rij may become 0.
But if you check for this and you say if it's less than 2, do nothing, you're right, it works. It's physically incorrect. It gives me indigestion. But it would or maybe that was the taco. But I had a little, that's too much BS added, yes. No, I think you're right. It's fine. It's fine. It'll look fine. And as I said before, in computer graphics, if it looks okay, it's okay. You're right.
So just to clarify, if you're above that threshold there, but within the threshold for checking, you recommend dividing by RIG magnitude squared instead of just the shift?
Yes, if it's above this threshold and below this threshold, I recommend dividing by Rij magnitude squared rather than just shifting 4 bits. Because shifting 4 bits will systematically underestimate the outgoing speeds or underestimate the deltas. Now, given that you've gotten rid of the really aberrant cases here, it probably will look approximately okay. And if you've coded it that way and it looks okay, leave it.
So if we have a number of balls on the screen, so would you want to maximize the number of balls? Like, wouldn't that, so if it looks okay by shifting, then
Leave it.
leave it, because that means you can have more balls on the screen.
So divide is certainly slower than doing a right shift. However, this brings me back to what I started to say before the question, and that was overclocking, why you shouldn't bother to try and overclock. And it's related, and that is that the slowest operation by a good deal is going to be updating the screen. And the TFT has a hard maximum SPI speed of 20 megahertz. Therefore, if you overclock the CPU, you have to underclock the TFT. And so let's say, right now it's set to 40 megahertz. Divide by 2 is an SPI divider. That takes you to 20 megahertz, which is the maximum SPI speed for the TFT. Let's say you go to 50. Uh-oh. Now we have to do a divide by 4 because 25 is too fast for the TFT. So we have to do a divide by 4 and run the TFT at 12.5 megahertz, which actually pessimizes your code. That's the opposite of optimizing. Is pessimizing. So it's going to pessimize your code by 20-30%.
I'm not seeing still how that pessimizes their code though in terms of the TFT. So it's like the TFT is much slower to all the calculations going on.
So the TFT is slower, and since you have to erase and write every ball, and that's directly in the loop, it's going to slow the whole calculation down.
Do we have a quicker way of sending and receiving information instead of using SPR?
Nope.
I2C,
I2C is definitely slower.
anything that's quicker?
Not that's implemented on that TFT display.
Why is the SPI like naturally slower, like by that much?
So the SPI channel is limited by some sort of microcontroller running on the TFT display. And it's also limited by the impedance of the wires. And if you look at the waveform of the 20 megahertz SPI running on those on the boards, you may well find that the clock line, you expect the clock line to look like this, and what it probably looks like is something like that, because of the impedance discontinuities in the board. You speed up another factor of 2, and you have a sine wave. And now it doesn't work anymore. Last year, when we were running these through the solderless boards, the TFTs were on solderless boards, they weren't on the prototype board, the clock was so degraded, I could not believe it actually worked at 20 megahertz. The effective bandwidth of a solderless board, of the white solderless boards, is about 10 megahertz. You don't think of this stuff as being slow, but it's slow. Why is it slow? Why is it slow? Why are the whiteboards so slow?
Is there like some sort of capacitance in the board that's like?
There, it is exactly what it is. There's a parallel capacitance because if you look at these lines of holes, if you look at that line of 5 holes on there and look at it from cross section, look at it from this side, you'll see that there's a metal channel like this. And the next one over is a metal channel like this, and that is a 20 picofarad capacitor. Oh, it's huge compared to everything else. It's between 10 and 20 picofarads. It's huge. Huge. Bigly. It's very bigly. And it low pass filters all of the signals that are going through the whiteboard, through the solderless board. So you cannot run those above 10 megahertz with reliability. At 100 megahertz, they're a complete short. I've seen people try and put 400 megahertz transceivers on the boards, and nothing comes out of the RF port at all. Don't overclock. Not worth it. Any other questions about Lab 3 at this point?
Just as a general question, say we don't overclock for this lab, but if we get to 60, would dividing by 3 work?
The question is, if you got to 60, would divide by 3 work? And the answer is there is no divide by 3 on the SPI. It's all even numbers. I looked through in some with that very thing in mind, with that very consideration in mind, I was plowing through because you could set the baud rate generator to any number, but there's a factor of 2 it's multiplied by. So you cannot set it to an odd number, in fact. The divisor can't be set to an odd number. It's any even number between 2 and 1024. Everybody's really okay with Tuesday moving to Wednesday, graded on Wednesday, huh? Nobody's overstressed by this?
Move it to Friday?
Well, see, that seems unfair to everybody else.
What do we mean?
But that was it. Why don't we move? That's a great idea. Move the Thursday lab to Tuesday.
Perfect. That's it though.
Yeah.
Sleep it.
I think you're joking, I hope. Okay. So it stands that Tuesday gets graded out by Wednesday night, 7:30. As a matter of interest, to me at least, I recoded the ball bouncing example on the development board page. So the animation example, ball bouncer, I changed to using the XC32 built-in floating point support, which now exists, by using the type _accum, which is a signed 16 bits and then 15-bit fraction. So it's 1 bit less precise in terms of fraction and has 1 bit more of integer, which means that the overflow changes slightly. So instead of overflowing at 100, so now if I take some accum squared, instead of overflowing at 181, where does it overflow? 16 bits, folks. Square root of 16 bits is 8 bits. So it overflows at 256. That's the only real change in the behavior. You still have to do the check if you use this system. You still have to check and make sure that the balls are less than 4 apart before you do the detailed distance check. But coding becomes a little easier. At least it looks nicer. The code looks a lot the same. So I'm declaring types now of a cum of x and y. And I wrote a new macro, which is int to a cum, which really is just to cast using the accum type, because now accum is a built-in type. But I think casting to an underscore accum is just homely. So I wrote a macro which hides it behind the macro interface. But you don't have to. Then the computation becomes the two fixed point numbers. You just multiply it, because now the built-in multiply type works with fix. You multiply, you add, you do an int to a cum of 5. You have to be consistent, of course. The code looks generally cleaner. It's no faster or slower, so it doesn't really matter much for this lab. But in the future, I'm probably going to recommend that people use it. Question? Yeah. So, what other questions do you have about Lab 3? Everybody got balls bouncing at this point? Pretty good? Yeah.
So I actually came up with this conflict for the Tuesday lab being due Wednesday. So if we actually go on break like we're supposed to, right, everyone in Wednesday lab and Tuesday lab will now be trying to work all of Wednesday to finish their lab. And we might not have enough space. So since the Tuesday lab is actually losing priority lab time of 3 hours, and then on Thursday everybody will be working on Thursday, you know, et cetera, et cetera. I don't feel like it's entirely fair.
What would be fair? Oh, so we come in and demo on Saturday?
I mean, we can do the next week, but I guess.
No, that's grossly unfair in terms, yeah. What would be fair?
I think I'm in Thursday lab. I think it would be fine to extend the Tuesday people till Thursday, just out of.
What about like
Out of kindness? How about, oh, that's interesting compromise. Done by noon Thursday.
Because then you have that period.
That way you don't interfere with the
The
Wednesday folks too much, or the Thursday folks at all. You have an extra 12 hours, 24 hours. What do people think? Is that's a positive expression.
I think that's fair.
Are you on Tuesday?
Yep.
Yeah, okay. Just checking. Are people happier with that? Is there anybody who thinks there's a downside to that?
Thursday.
And by the way, no, that's too long. And by the way, since these due dates were announced the first day of class, it does not count that you're not supposed to work over break. When you signed up for this class, you signed up to do this for that Tuesday. You might not have known it at the time, although it was implied. See, anything that's scheduled from day one is fair.
And everyone just schedules everything they want.
Why not?
I feel like that's such a loophole for classes.
But that way, that allows you to plan your life completely, for better, for worse, right? And freshman year, I got every physics assignment the first day of class. All the homeworks, were given to us in a big folder. That is like a gift that eats. That's like giving somebody a goat, right? Because when are you done? Never. So there's a mixed blessing to knowing everything the first day. But the fact is, the rules say, if I announce it the first day, it's fair game. Now I'm willing to do this till Thursday noon. That makes sense to me. Let me see what my schedule is like Thursday morning before I commit the TAs to. So I have to give a 10:50 class at 9, so I couldn't actually check people out until 10. I could open up at 8 o'clock in the morning on Thursday. I just won't be there from 9 to 10 because I have to go do a 10:50. You still okay with that? Okay, so the official is due by noon on Thursday for the Tuesday people. Yes? Any more discussion? Anybody feel that's so on the balance that's fairer? Front row people say yes. Must be true. Did you have a comment? Was there? Did I see? Yeah, okay. Okay. Thursday it is. I'll put out a piazza correction on that. Now, what else do we need to know for Lab 3? Let's just do a little teaser for Lab 4. Because it's coming at us like a freight train, folks. Oh, and also, of course, next week in lab at night. Is it night before lab? Homework 5 is due, right? Yes, due the night before your lab section at 23:59, the week of 10/9, is homework 5, which is the final project proposal. This, however, is really easy to do by email, so you can do it all over break.
So
Night before.
So that one's still due Monday for the Tuesday lab, right? That's the night before.
Oh, you make life so difficult. This is why next year I want to get rid of the Tuesday section. I want to move it back to Wednesday afternoon.
I'm fine with it. Like,
Would anybody? What do people think? Why don't people sign up for Wednesday afternoon? Is it because there's a conflict with something else?
I mean, it's the middle of the week.
It's a week. Oh God! I was afraid you were going to say
I
that.
mean, that's true.
I originally was in the Wednesday, but I had to switch because
Okay, so we will make it the night before your lab section. So we'll make that
Monday.
Monday. No, I'll make it Wednesday night. For the, if the lab is due Thursday, the homework is due Wednesday night. But folks, you should have been working on this one already. Don't wait to the last minute to pull something out of your ear for a final project. Start on it last week, because this is non-trivial. 1 degree of freedom helicopter. So I fiddled around quite a lot trying to make this work. And yes,
If we have a prelim during the 4:30 or 7:30 lab.
4:30, 7:30. Which 4:30, 7:30 lab?
Thursday next week. Do we just like check off, like tell you to?
So does everybody in the group have a prelim the same night? You could, if one person is missing, you could have the other person do the checkoff, even though that's suboptimal in terms of satisfaction all around. Otherwise, you can check off before. Because that, I mean, that is clearly planning your life, right? So for this, what I'm going to have you do is to build. So you're going to build this device, which is a I'll just draw it out. So what we're going to do is from the, now this is the front view. There's going to be a potentiometer with a knob on its face, and you're going to hot glue a wooden beam to the potentiometer. On the other end of the beam is going to be a drone lift motor with a little propeller about an inch in diameter, excuse me, 2.5 centimeters in diameter. And what I want you to do is to hover this. So the potentiometer is going to be bolted to the tabletop, and this arm will be free to swing, and the potentiometer will measure the angle of the arm, and the motor will lift it. Motor runs at full blast at about 3.5 volts or so. At about 12,000 RPM, it draws 100 mils or 150. Actually, it draws almost a half an amp at 12,000 RPM. So it cannot be run through an I/O pin. All right, and I did a test. I ran this thing wide open and stuck my finger into it.
That was your first test?
That was the first test I did with the motor.
Think about a pencil? Like...
No, I didn't want to break the motor. Of course. And it hurt. It didn't draw any blood, though. So I think it's safe enough. However, you are going to have to worry a little bit about running this into your face, and you're going to have to worry about running it into the tabletop, because that will break the motor. So this is going to be mounted on a little bracket, which I'll give you, and a little piece of wood, which we'll give you. And my guess is that you're going to want to make some sort of wire thinger that's going to stick up above here and stick out, so that when the beam comes up here, it hits the wire and doesn't go over the top and give somebody a haircut, or hit the desktop. So you're going to want to have a stop on this side and maybe a stop down here, because it's probably going to hang over the edge of the desk. And what I'm going to ask you to do is at boot time is to run this from minus 90 to 0 degrees, up to plus 30, back down to minus 30, and then back to 0. So that'll be the test sequence. I want it to be critically damped. I want it to not overshoot too much. I want it to settle quickly. When you step it from 0 to 30, I want it to go like this, up to 30 degrees. I do not want it to go like that or like this. One overshoot's referred to as critical damping. I would like you to be close to critical damping. So, and to drive this motor, you're going to need a motor control circuit, which is going to be a pass transistor and an opto isolator. And the reason for the opto is that these little nasty DC motors make a phenomenal amount of spike noise. Phenomenal amount. Enough to reset the CPU 100 times a second. So all of the motor noise is isolated over here in this circuit, where this is going to be the bench power supply. Bench power supply. There will be no connection between this circuit and the CPU. Yes.
What is meant by spike noise? Just like the fact that it like reacts really quickly.
So these are brushed motors. They have contact brushes in them, which means that they are also spark gap transmitters. So if you look at the voltage across the motor, when you turn it on, it's going to look like this. The average value will be related to the applied voltage, but the instantaneous voltage will be up to 100 or 200 millivolts different than that, and the bandwidth of that signal will be 200 kilohertz. So it's going to look like every time a spark jumps across this gap, you're going to get something that looks like that. So that's what I mean by spike noise. It's really fast noise, so it's wide bandwidth. Really hard to filter. So there's going to be long wires going out to the motor. There's going to be wires from the potentiometer back to the signal processing side of things. And what you will find is that if you lay these wires next to these wires, that the amount of noise that gets back into the signal input will be so great that it will destroy your control circuit. So you're going to have to worry about the geometry of the circuitry itself. You're going to have to think about layout. You're going to have to think about keeping the wire motor wires separate from the signal wires. The signals are going to come out of the angle sensor, which is a 10K potentiometer, go through a simple low-pass filter, where you're going to choose C for whatever bandwidth you think you need, and then through an op-amp follower and into the ADC, the analog to digital converter on the microcontroller. Yes?
Is it worth wrapping the motor wire in aluminum and grounding it?
I don't think it's worth wrapping the motor wire in aluminum foil and grounding it, because I think you won't be able to lift it.
No, that's going to be thin, right? Really light.
The total lift on this motor is only about twice the lift of the weight of the arm. So it's really close. Better to put aluminum foil around the signal wires if you find you need that. How will you find you need that? What will you do to check the signal integrity? Put a scope right there. Hopefully you should see no spike noise there. The low-pass filter should get rid of it, except for spurious paths you don't expect.
I'm actually still kind of confused on the spike noise. So you say that that's like what the one to the left, that's what the actual output is of the motor, right? But then these spikes are coming that it goes.
They're coming from the motor.
Yeah.
So the brushes in the motor commutate depending on the phase of the motor to keep the magnetic field advancing in front of the direction of the rotor.
But then why does it spike as it goes on? Like, why is it that it spikes so tall to the right, but then on the left it's like going to an image?
I'm sorry, this is a magnification of this. I'm just blowing this up so you can see the broadband right now. I'm sorry. Yeah. So, most of this lab is going to be hardware. You have to build this thing. You have to build the physical pendulum. You have to build the motor controller. I'm giving you a MATLAB simulator, which I think is pretty good. At least it produced waveforms that look to me like the scope output. I'm going to ask you to be able to show me the actual angle and the motor control parameter on 2 channels of the DAC.
Question.
Yes?
So in the PID, will we be actually able to input the gain and the integrator?
Uh-huh. So at the core of this is going to be a control algorithm which needs to run at a very fixed, uniform, high rate. That means that you're going to run the control loop in an interrupt service routine, probably running at about 1 kilohertz. So what would you guess that the period of this device is? What's the natural frequency of this system? It's about 1 foot long. Anybody have a feel for this at all?
It's like square root of K.
Oh man, this reaches back. Oh, it's the square root of L over M or M over L or
Stiffness over the mass or something?
yeah, maybe want to go back and look at Galileo's formula for a pendulum.
Oh, because it'd be moment of inertia at this point.
Yeah. It's square root of L. It's been a while, yeah.
What's that motor weigh?
Huh?
What's that motor weigh?
The motor, it's I don't know, a couple of grams.
Oh, grams.
It's really light. They're cute little motors. They're also cheap, which is important for this lab, because I suspect we're going to blow up a few. I'm not sure. You're going to build this, you're going to get the control circuitry all set up, and then you're going to drive a control algorithm which is going to be based on PID, proportional integral differential control. And before I got the PID working, the system was completely unstable. I'd turn it on, it's hanging straight down, I'd turn it on, and before it could stabilize, it would go over the top and run into my arm. Wham! And so you are going to have to add a lot of derivative control to this to stabilize it, and a little bit of integrative control, which you can see here how this value is creeping up out here. That's a little bit of integral control to get the error down. So program is going to be pretty simple. There's going to be a thread in which you input control parameters. And then there's going to be an interrupt service routine which runs the control loop at about 1 kilohertz. So about 1,000 times a second you're going to run the control loop. And that's because a pendulum about 1 foot long has a characteristic frequency of a couple of hertz. So 1 kilohertz control is probably fast enough for this. Also the motor, the time constant for the motor is something like 50 milliseconds or so. Revs up fast. So that's a little taste for Lab 4. We'll start on that next week, being Wednesday, and talk about the details. I've built a couple of these. It only takes us half an hour or 45 minutes to build one of these. We'll start next week.
So it must be like 2 phi f equals square root of L over